So James's obsession boils down to two things really. One, a robot vacuum cleaner has to work like a proper vacuum cleaner. And the second one is that it needs to be able to clean intelligently. Other robot vacuum cleaners don't do that. Some of them behave like this, randomly bouncing around. You go over some areas twice, they don't cover some areas at all. There are some that are more methodical in the way they clean, but none of them actually pick up very well. And those are the objectives that we set our engineers. That's what we started doing 16 years ago, and we finally managed to achieve them. Now, for the machine to be able to clean intelligently, it needs to understand and know where it is. And in order to do that, we had to develop a unique vision system. So in the centre of the robot, there is a camera. And the camera takes a panoramic image 360 degrees all around. It refreshes that image 30 times a second. And what the software does is it identifies key features in the image, reference points that it can use to triangulate its position, a bit like GPS satellites triangulate to identify where your car is using the satellite. So by using that triangulation, the robot knows exactly where it is. And this camera technology works in conjunction with infrared sensors along the front of the machine. So as the machine is travelling around, exploring its environment, it's building a picture of where there are obstacles. And as the picture becomes more detailed, the machine can plan more and more efficient maps to make sure it covers the whole area and cleans perfectly. And the image that's on the screen at the moment, the lower part of the image, this strip here, that's the panoramic view stretched out. And you can see there are kind of green circles, and the green circles, or the ellipses, are actually the reference point the robot is identifying that allow it to pinpoint exactly where it is in the environment. And the image above is the map that is of the environment that the machine is cleaning. So the yellow ellipses are those reference points. Those are like the satellites that it's using to pinpoint exactly where it is. The green are the paths where the robot has been, and the red round the outside, those are the obstacles that the machine has identified using the infrared sensors. So it's building up a picture of the room that it's trying to clean. When it completes the perimeter, it knows that it's cleaned everything that it can, and because it knows every point that it's been there, it knows that it hasn't missed anything. So you get intelligent cleaning that covers every part of the room. So that was how we solved that part of the problem. The other aspect of the machine is, well, how do you make it a really good vacuum cleaner in such a compact form? So the heart of the machine is the digital motor, the Dyson digital motor. This is very similar to motor to the one that we use in the stick machines. Because it's digital, the pulses, the digital pulses it uses to energise the motor means that it can spin incredibly fast. And so for a very small, lightweight, compact motor, we can generate very high suction performance. This is the first time a digital motor has been used in a robot vacuum cleaner. And as this is a Dyson patented, developed motor, that means that no one else can use it in their robot either. So we generate very high suction using this very efficient, high-performance motor. The next technology we use is the cyclone. So our engineers have miniaturized the cyclone to deliver very high filtration efficiency on the machine. So as the dust and the dirt comes in, it's spun around to incredibly high velocities in the cones, and that flings out the microscopic particles and the allergens from the airflow. And because it's a cyclone, it never clogs or blocks. So it means that suction remains constant when the machine is working. And the airflow goes through the machine, through the motor, and then there's a HEPA filter at the back. So the exhaust there is clean, it's perfectly clean. The other really important part of the machine is the brush bar. This is obviously the bit that's doing the work. So houses these days are multiple floor surfaces. They've got carpets and hard floors. So we had to design a pickup system that worked really well on carpets and hard floors. We designed it so the brush bar is the full width of the machine, which means it cleans right up to the edges. It means wherever the robot goes is cleaned. And the brush bar has two types of bristles. The red nylon bristles agitate the carpet surface and mean that we get really good pickup on carpet. And the black ones are carbon fibre, and they allow the machine to pick up fine dust on